Morning first year, hope you're all well and hope you had a lovely weekend. Okay, for the work for this week, if we go into files, elements in the periodic table, and we are now on week 7. So it's the elements tasks for week 7. So I'll talk you through what I would like you to work on this week. Wee bit trickier this week, just to let you know. So it's really important, if there is something that you're not sure about, that you do ask for help and you do come onto Teams and get some help with it, okay? So a few weeks ago we were focused on what substances could be, whether they are elements, mixtures or compounds. What we're going to focus on this week, first year, is compounds. So we're going to be learning about forming, how compounds are formed and how we go about naming them. So success criteria for this week is that you can state what is meant by a compound. We already covered that a few weeks ago, but it's important that you do know that before moving on. Identify some properties of metals and non-metals. Again, we looked at that last week, but we're going to use it again. We're going to be using our listening and observation skills to identify key parts of an experiment between two elements, magnesium and oxygen. We're going to be using our literacy skills to write a scientific report for this experiment. Now, don't be put off by that. There'll be lots of help for how you go about doing this. And then we're going to identify elements found in a compound from the name of the compound. So, work for this week then, a few different things I'd like you to do. What we're looking at is we're wanting to learn a bit more about how compounds come about. So we should know at this point that compounds are elements that are chemically joined together. And what makes them different from a mixture is the fact that they're chemically joined together. So what we're going to look at this week is, well, how do you chemically join elements together? What's the difference between just having elements that are mixed together in a mixture? How do you get them to chemically join? Now, you may have remembered from a few weeks ago, I spoke about Skittles, and Skittles or M&Ms being a good way to think about your elements, compounds and mixtures. And what I said is, if you've only got one colour of Skittle, if they're all red, then that's like an element. If you had different colours of Skittles all in a bowl, then that would be a mixture, because you could easily just pick out the colours. But if you had a bag of Skittles in a bowl and then you heated them up until it became like a gooey mess and it was all stuck together, that would be more like a compound. So I want you to think about what we did to them, to the Skittles. We heated them up. So what you need to do, if you're wanting to form a compound, you need to give the elements energy to get them to join together. Normally that energy is heat energy, although you can use other types. So we normally burn elements together to get them to chemically join. So the first part of this week is these 3 videos here. There's a very simple experiment that shows a compound being made, and it's all about burning magnesium. Now, ideally we'd be in the classroom and you guys would get to do this for yourself, but we're just going to have to make do with watching a couple of videos about it. So there's 3 very short videos here showing magnesium being burned. So I want you to use your observation skills, pay careful attention. What do you see happening here? We're then going to write this up as a scientific report, and I'll show you the file in a second. So we're going to be looking at this reaction now. We're burning magnesium, and what we're reacting it with is oxygen, because we need the oxygen in the air for burning. So we're looking at here of magnesium and oxygen combining to make a compound. Okay, so I'll show you this document in a second, but you're going to copy and complete a table. There's another video here about the reaction of magnesium and oxygen, but it goes into a wee bit more detail. And then you're going to use the headings from the scientific report to complete pages 2, 3 and 4. And then there are some tasks on 5, 6 and 7 for you to try as well. You can write the answers in your jotters on paper or download a copy of the Word document and type your answers there. And then this week there will be a quiz that will be posted on Wednesday for you to attempt. You don't need to upload your work this week. If you want to, that's absolutely fine. You can take a photo and put it onto Teams, that's fine. But we're just looking for the quiz to be handed in this week. Okay, so what is it that you're going to be doing then? Okay, so this table is going to help you to try and have a think about what magnesium and oxygen are like before we put them into a compound. So using your knowledge from the previous weeks, or you might need to do a wee bit of research on the internet, you're going to fill out this table for magnesium and for oxygen. So whether it's a metal or non-metal, you might want to use your periodic table for that. Solid, liquid, gas, is it strong or weak, and so on. So it ties in with what we did last week, and you're just going to fill in this table for magnesium and oxygen. That's to get you thinking about what they're like before they become a compound. So you're going to watch the video that's in the checklist. You're then going to write a scientific report based on this video, and anything that's green you can copy down to help you write the report. So we've really broken the report down a lot this week. If we were in class, I wouldn't have broken it down as much, but scientific report writing is a skill and it can be quite tricky. So I've given you a lot of help with it this week, just so that you can have a go at home. But anything in green you can copy out and then you just fill in the blanks. So scientific reports, we have done them in class before, so we know that we start off with the aim, then we do our methods. Now write 2 to 3 sentences that describe how the experiment was done. So obviously you haven't got a chance to do it, but you should be able to describe it from the video. Very, very simply describe it. You don't go into a huge amount of detail. It should be clear. It should be bullet points if you want. But basically it's like a little recipe. If somebody else wanted to repeat it, they could copy your method. Diagram's already done for you. Again, feel free, guys, if you're doing this on paper, to draw your own diagram. It doesn't have to look exactly like that. It could actually probably be better if it was a bit simpler than that. But obviously feel free to use the diagram that's here as well. Now for the results, you're obviously going to have had a look at what's happened in the video, and you're going to fill out what's happening when the magnesium is burned. So it reacts with something in the air, and the magnesium burns something, which produces lots of something and something energy. So I'll not give away the ending. You can have a look at the video and see for yourself what you think the answers to that are. I should note that I'll post the solutions later on in the week, so you can still check to see how you did without submitting your work. Okay, so now complete the table. This tells us what happens. So if you look at this table here, you've got elements, what the name of the elements are and what their appearance is like, and then the name of the compound and what its appearance is like. So you're thinking about what it makes at the end of the video. And I'll talk about naming the compound in just a second. So you're going to put in oxygen, magnesium, and the appearance of what they're like before, and then the name of the compound and the appearance of what it's like after. And then your conclusion, when something reacts with something, it forms a substance called something something. Now, that's the experiment, so hopefully it won't take you too long. It is kind of just filling in the blanks. Again, any questions about it, please just ask. The next sort of section is about naming compounds. Now, this will probably help you a lot with the end of the experiment when it says a substance called, because at that point we want to be able to say what the name of the compound is that's been made. So when we take magnesium, combine it with oxygen, it becomes a compound, but how do we know it's a compound? And it's to do with the naming of it. So if we look at this second bullet point in blue here, from the experiment that we saw that magnesium oxide is a compound formed from magnesium and oxygen. So the compound name is called magnesium oxide. And we know it's a compound is because we've got our 2 element names, but it ends in IDE. And that tells us that it is a compound. So here's some more examples to help you with that. Calcium oxide has got the elements calcium and oxygen. Okay, so we look for the names of the words in the compound, and we think about what those elements could be. Calcium oxide has got calcium and oxygen. That IDE at the end tells us that it's a compound. Iron sulfide contains elements iron and sulfur. Copper chloride contains the elements copper and chlorine. So you might need to look at your periodic table if you're not as familiar with the element names, so that you can see which one you think it's going to be. So based on that, I'm going to give you a couple of tables for you guys to try for yourself using what I've just spoke about. So for example, the compound iron chloride, you need to think of the elements present are going to be iron and then chlorine. So look at your periodic table. There is no element called chloride, but there is one called chlorine, and that's the one that's there. And you're then going to see if you can name the compound based on the elements present. So for 4, 5 and 6, you're told hydrogen and fluorine. So that would be hydrogen fluoride. Sodium and oxygen, and you're going to try the next couple yourself. Okay. Now, the next page is actually a little bit trickier. So don't worry if you don't get to this page. This is like an extension task for anyone who seems to be coping pretty well with this. But it does get a little bit harder, because quite often when we make a compound, hopefully you'll remember me saying it's 2 or more elements chemically joined together. And quite often we'll have 3 elements joined together, and one of those elements will be oxygen. So how we go about that then is when we're naming our compound, rather than having 3 names, so for example, number 1 here, calcium carbonate, is made up of calcium, carbon and oxygen. So rather than having the name calcium carbon oxide, what we do is rather than the IDE at the end, we put ATE at the end. And that means that there's oxygen present. So there's 3 there, and the ATE tells us that oxygen is present. So for the first one, calcium, carbon and oxygen are the 3 elements. Now, like I say, first year, that is probably messing with your head just now. That's a lot of information to take in. So like I say, if you can have a go at this page, excellent. If you feel like you're struggling and you are trying your best with this one here on page 6, then that's absolutely fine as well. And if there is anything that you're not sure of, then please just ask on Teams. I'm hoping to have a drop-in session with you on Wednesday afternoon, and I'll upload the times of that. So please make sure that if you are struggling with anything this week, that you do pop on and ask any questions. Sometimes even just a wee 5-10 minutes of me going over something and the live lesson just can make it sink in a little bit better. So please, if you can make it to those drop-in sessions on Wednesday, then please make sure you do. Okay, so hopefully that makes sense. First year, like I said, a wee bit trickier this week, a wee bit more to it. So just as usual, to keep track, just make sure you're working your way through the checklist. That should break it down for you so that it doesn't become too overwhelming. And like I say, any questions, just ask.